Good day, students. Happy to have you once again in this class, economics class. We have been able to introduce the subject to you, and I'm sure you were happy to learn about the subject of economics, how it affects you personally, how it is that it is what you do, you engage in it. You engage in it directly or indirectly. And it's awesome to know about that. It's very exciting because it's something that is involuntarily done by everybody, every living being, all right? So you can't say that you don't want to study economics. No, it's not proper to say so because whether you know it or not, you are engaged in it. So the study actually gives you more tool, more strength, more ability to make the best out of your life. Okay, so yeah, let's go into it. This time around, we are going to look at the topic titled Basic Tools for Economic Analysis. That is, those tools that you can use to create some awareness for yourself as to what is taking place around you, okay, and make some calculations, reach some conclusions, all right, to give you a better view as to what you should do, all right. Those are the things we call the basic tools for economic analysis, okay. So let's dive into it. For this topic today, we're going to do the following. We're going to explain the following, that is table, graphs, and charts, okay? Then we explain the frequency distribution, and we do a sample of it, okay? We'll construct a frequency table by doing so, discuss the measures of central tendency, the types, and the advantages and its advantages as well. So these are the scope of our study for today. Let's see how we're going to go through that. Now, what is table in the beginning? This is one of those tools we're talking about. What is table? A table can be defined as a systematic and orderly arrangement of data in rows and columns for easy and better understanding. If you open any material, you see a table. You can easily tell what is contained in the table. You can tell what item represents what, and at what degree of quantity it is done. So you can actually make outright sense and meaning from what you can see in a table. So it means that it has been systematically and orderly arranged in rows and columns for your easy and better understanding. So you can see that's what the table is. Okay? We'll show you a table as we go on, all right? So just let's finish up with this. What and what must you see in a table? What and what must make a table to be what the table is? That's talking about the features of a table. First, in no particular order, it must have or must be very simple to understand. Like I said, when you look at a table, you know what and what is there, all right? Nobody will need to explain to you most times what is in a table. It must be easy to understand. You have an easy understanding for it, okay? It must have a title. Of course, what a table is representing must be known instantly. Okay, this is for timely cost of students. Okay, fine. This is for item purchased. Oh, this is for demand for the time. This is sales that have been taking place. All right, you understand? So the table must have a title for easy reference. The units of measure used in the table must be stated if there's need for units, all right? You are talk about scaling of the table, or you must use unit if you have one. Okay, the purpose for constructing the table must be stated as well. That is, maybe yearly information or monthly information, weekly information as a particular item is being recorded, okay? Then you have the source of information if you have one, all right? You can state it as well. So these are the things you must observe about the table, which makes the table reliable and useful and usable. Okay, these are the things must be very simple, easy to understand, must have a title, it must have unit of measure, all right, stated if you have one, then the purpose of which the table was constructed must be stated, and then the source of information, where you got this information, you can also state it if you have one, all right? Then, how is important a table to us? Why is it important for us to have a table? Because it helps us to summarize data. You use a table to what? To simplify a data, all right? It helps us to orderly arrange data. This is important because it helps us to arrange data in orderly manner, okay? It makes a comparison between two classes of data easy. You have last week and this week, this year and last year, next month and this month, all right? Between two students, between two companies, between two communities, right? Between two countries, you have tables. It helps you to make comparison between two classes of data for you, okay? Then a table helps us understand data. Of course, looking at the two of them is, okay, this is this way, this is that way, and it helps you to make your conclusion about the two variables you're looking at, okay? Then it makes it easier and faster to make decisions through the use of table. You can decide easily when table has been made available to you to do a comparison. You can decide quickly, all right? That's how important table is to us, okay? A graph. One of those tools that we use to analyze economic phenomena, a graph or graphs. A graph is a diagram that shows the functional relationship between two variables. Functional what? Relationship between two variables. Examples. Example is the relationship between two variables is between price and quantity demanded or bought, or price and quantity supplied, okay? Yes. The most common example is what? Prices and the quantities demanded or supply of commodities, okay? So yes, we have that. It shows a functional relationship between two variables, especially price and the quantities supplied or demanded for over a given period of time, okay? Features of a table include the following. Table must have a title, just like, graph must have a title. It must have a title, of course, to know exactly what the graph is representing. It must have appropriate scales, because when you put that in a graph sheet, you must tell us exactly how you have been able to measure out what you are using on the graph, okay? All graphs must have two axes, which is the x-axis and y-axis, okay? Then graphs must be labeled properly for better understanding. You must tell us, is it a demand curve you're drawing there? Is it a supply curve? Is it a utility curve? Is it a production curve? Whatever it is, you must tell us exactly what you are drawing on the graph, okay? Then graphs must show the source of data presented. When was this data, where was this data gotten from? All right? The source must be also labeled or written there if you have it. The x and y axis of the graph must carry different variables. Sometimes it may be uniform, but sometimes they carry different variables for accuracy and proper analysis, okay? So yes, this is for graph. Then you can see what you have here is a very clear picture of what graphs are, okay? From the left side, you see what? A demand curve, showing the relationship between what? Price on the vertical axis, quantity demanded on the horizontal axis, all right? That means for the price one, quantity one was demanded for price two, quantity two was demanded for price three, quantity three was what demanded, that's ABC. So yes, it shows the relationship between what? Prices on the axis, vertical axis, and quantity demanded on what? On the horizontal axis. Yes, that's what it is. So, but the second graph here means combines both supply and demand together to show us what? The equilibrium condition in the market. So yes, these are what I want to use graphs for, okay? How important is a graph to us as economists, all right? Even to everybody, of course. It helps to show the relationship between two variables, like I said earlier on, demand and price, supply and what? Price. It helps to interpret values of variables. You can see if we have quantities and prices inputted in the one we have before now, yeah, this is, you may have, okay, maybe for 2 naira, 10 was demanded for 5 naira, 3 was demanded for 10 naira, 1 was demanded, it can be like that, right? So this, it helps us to be able to interpret variables, okay? The third one there says it makes clearer and quicker impression about quantitative information. You can say, actually, it is true that even as price is rising, demand is actually falling, all right? Yes, it gives you that impression to see that clearly, demand will drop if price increases, okay? Yes. Then graph makes it possible for changes in variables or quantities to be observed or expressed. You can see it clearly. The pictures are there, the numbers are there. It gives you a clear picture of how variables change over time, all right? Then what are charts? Charts. Charts are other means of presenting quantitative information in a way that makes it easy to understand, okay? All of them make sure that it gives you easier understanding than it should have been when written in theoretical format. When you put any information in a table that is theoretically analyzed, you can see it becomes more easier to grasp and understand and even to make decisions. Yes, we have two types of chart basically. What is that? The pie chart and what? The bar chart. The pie chart and the bar chart. These are two very common types of charts that we have around us in analysis in economics. But the second one is divided into two or even more types, okay? First, we'll have a simple bar chart, we'll have a component bar chart, we'll have a multiple bar chart, and then histogram. Of course, we have another one that's not listed here, which is what? The pictogram, okay? Pictogram is another kind of a bar chart that we have. All right, so we'll talk about them as we move on further. So please take note that we have two common bar charts, a pie chart and the bar chart. Bar chart comprises of what? Simple bar chart, component bar chart, multiple bar chart, and histogram, as well as what? Pictogram. Okay, what's a pie chart? A pie chart can be defined as any circle of any size, divided into sections or sectors, with each sector proportional to the quantity or value it represents. Circle of any size or section, with each sector proportional to the quantity or values they represent. That is what a pie chart is all about. It's a circle of your choice of size, of which you're going to construct and use it to represent variables in their proportion for each sector, all right? Now, how do you construct a pie chart? You must, first of all, come up with a total, the sum of all the variables put together, out of the quantities or values of the products under consideration, all right? Get a total of the values you're looking at. Of the individual variables, get a total of them. You must start from that point. If not, you may have a problem going further with pie chart consideration. Now, work out the values of the various products or variables in percentages or degrees. First of all, please remember that in doing a pie chart construction, it is mostly what? In degrees. Percentages come in by choice, all right? It's not mandatory, all right? But you must, first of all, consider it as a degree because we're talking about circle, all right? A circle has what? 360 degrees. So your construction or calculation must be, first of all, considered in what? In degrees. Percentages are just an addition, just in case you need it for further analysis. They are not compulsory, right? But please, it's something you must also look at. But first of all, it's what you have to go through it as a degree because you're looking at a circle as your tool, all right? Your tool there is what? A circle, which is 360 in degrees. So yes, you have to calculate in degrees first with. Now, number 3 is draw a circle of any convenient size of your choice using what? A compass. Okay, then divide the circle into sectors subtended by angles or values calculated in your calculation in degree. Now you have to construct each sector or section in accordance to the degree you have derived in your calculation based on the variable in question, all right? So for each variable in the total, you calculate the degree from the circle to represent it in the circle that you already have drawn, okay? Then write down the percentage of degree of each sector by it. Inside of it, you put it down by the name you have for that variable. Write it inside, or if it's too small, you can create a key and put the key accordingly. Write the name of the title of each variable, put the size of the degree alongside it, and then you have an image that will show exactly what that sector represents accordingly, all right, inside the circle. Then use key, as like I said, where information cannot be written inside of the circle as well. So yes, thank you very much. This is how you can draw a pie chart successfully. Remember, your examiner will be very meticulous in checking the angles you have constructed. If they tally with the degree you calculated, of course, they also check whether your calculation is very correct. So be careful so you don't lose marks if at all, or you don't make errors where these are going to be used to make decisions. All right, please, they're very important. Thank you. So looking at this picture here, you can see an image of a pie chart, divided into sectors or sections, as the case may be. You have, this one is talking about countries of origin in 2005. All right, Americas have 25%. You have Asia have 43%. Europe has 27%. These are countries of the world. All right, this is 2005 yearbook of immigration statistics. All right, so these are the people who have journeyed into different countries in that particular period of time. Other countries have 5% people coming to them. America's 25% of the world population went into that place, all right, living there. Then Asia 45%, 43%, while Europe is 27%. So these are the things you look out for. These analyses are made us understand that immigration happens in these countries in these degrees and quantities, all right, of persons, all right. So yes, we go back to our bar charts. Our bar chart is a graph or a chart that is made up of rectangular bars of equal width, all right, equal width, horizontal size, all right, equal width, but whose length, the vertical size, are proportional to the quantities they represent. You take the bars up, all right, according to the proportion of each variable in the total, all right. Yes, it represents a graph or a chart that has rectangular bars of equal width, but whose lengths are proportional to the quantities they represent according to their variables. Like I said, we have various bar charts. We have the simple bar chart, the component bar chart, multiple bar chart, histogram, and pictogram, okay? So these are the examples of the various bar charts that we have for your consideration. You see, this picture here is a simple bar chart. Let's go back. A simple bar chart is what? Is a bar chart that represents each variable with a single bar. In any information given to be drawn in a bar chart, use a single bar to represent each variable. That makes it what? A simple bar chart, where the variable contains just one variable per, one information per variable, all right? You give it one bar accordingly. You have component bar chart. This is a bar chart which contains two or more variables in a single bar, all right? Two or more variables in a single bar. A bar, we have two or more informations that represent a particular variable, okay? That's what we're talking about. So whenever you see such a bar, you know that we're talking about what? Component bar chart. Then multiple bar charts are the ones that have two or three bars for a particular variable, right? It contains two or three bars to explain a particular variable's content or information. So yeah, that makes it what? Multiple bar charts. Then histogram are various bars that are drawn for various variables, but without a space in between them. All right, histogram has bars joining together one by one, carrying one information against the other, but they are joined together without a space. That's histogram. Then pictogram is a bar chart that has images of the items being represented according to their numbers in height. All right, so this is more tedious. You can't mostly draw them in class, except using a computer system to just display it. So let's see what we're talking about in images. This is a simple bar chart. You see, for apple, we have just one bar. For banana, we have what? Just one bar. For grape, we have what? One bar. Orange, one bar. Pears, one bar. But you see, the height differs. All right, for grape, we have just 40. Sorry, for apple, we have 40 units of apple. Okay, banana will have the highest number, which is 60. And then grape will have just 30. And then orange is the second highest, 50 units of orange. And then we have 20 units, 25 units for what? Pears, right? So this is how we represent information in a bar chart using what? Simple bar charts. So very simple as the name is. It's very simple. So you think it's a very beautiful bar chart too. This is what component bar charts. A component bar chart, like we said, contains two or more variables, information in a bar, all right? One bar carries two or more informations concerning a variable. Now, in this case, you can see this bar, right? We have eligible for indoor games, all right, for fairly league. And then you use US history grade, okay? I have, see, each of the bars has 3 colors, in fact, 4 colors, right? The first one doesn't have 4 colors. Second one has 4. The 2 extreme doesn't have 4 colors. Those means those colors represent something that has an information that has to be shared. So you see, you represent according to the numbers on the vertical axis. When you're trying to talk about particular information, if you have a key here, the key would have told us that this green bar represents this particular variable, this yellow represents a particular item, the blue represents this. So you can see the volume of each of those colors tells you the number that represent in the bar. So you count one out, it represents that volume for that particular item. So yes, that's what it means for the bar chart. So have component bar chart has 1 bar representing 2 or more items for a variable, all right? Then multiple bar charts, another one. See, wow, beautiful, 2. This is a case where we have 2 or more bars representing what? 1 variable. In this way, category 1 has 3 bars, 2 has 3 bars, 3 has 3 bars, 4 has 3 bars. So you see, series 1 has blue, all right? Series 2 has red, series 3 has green. So you can see that series 1 in first category has the highest value, 5 or 4.5 as the case may be. Then series 2 in category 2 has the highest value. Same number with blue in series 1, all right? And then in category 1. In category 3, blue also has what? The highest number, which is series 1, all right? Then in category 4, both green and blue has what? The highest value. So in this case, you can actually determine what you're looking for. So you know how things have happened over the time. It gives a decent information as what has happened over the years or over the time as the case may be. So you can give information and make decisions accordingly, all right? This is what histogram. Histogram is a bar chart, like I mentioned before, that has each bar representing a variable, but they are not separated by any space. But in this case, where you have 0 as a figure or you have a negative figure, that's when you have space created between one bar and the other, all right? Here you have a negative value according to mathematical graph. You see, from that point where you have 0, going downward is a minus. So the 1, 2, 3, 4, the 5th bar is, downward sloping, all right, below the origin. So it's what? It's a negative value. In this case, it has what? It has become negative. So you draw the bar downwards, that's after you have space between blue and red there. If the number was actually 0 still, you don't have any value there, whether below or above. So you have a space. So wherever there's a 0 value, you have a space between the bar in histogram. So that's what we have here. So yes, take note of this. This is a histogram that shows average growth between 1997 and what? 1999. This is the title of this bar graph, okay? So okay, that's what it is. So let's look at some simple illustrations to complete this part of our analysis on what basic tools of analysis in economics. So we have small illustration to show you, okay? Now, we're talking about frequency distribution. What does it mean? It refers to the arrangement of data or information in tabular form to reflect the frequencies. Whenever an information is given in raw format, if there are many, for you to organize them to be meaningful to you, so they can use it for analysis, you have to first of all do a frequency table arrangement, okay? For example, you have this is here, you have this one here. What you do is to arrange this information in an ascending order is the best way. Don't do descending, of course, it's also it's not bad, but please do it in ascending order so that you can have a clear view as to what you're going to do first to do your frequency table. All right? Fine. I think we're going to do small exercise here, all right, on a whiteboard. Like I said, this information you have here, you're going to present it in a frequency distribution table. So we have to present the marks scored by 30 students in economics in SS1 in a frequency distribution table using the following data. So yes, let's look at it. Like I said, you arrange this information in an ascending order first so that you know exactly what you have with you, okay? So we can easily do that by saying the list of them we have there is 2. So we can say 2, another 2, because we have another 2 there. Then we have 2, 2, and then we have 4. So how many 2s do we have? We have just 2, 2. Then we have 4 as well. We have 4, 4. I think we have another 4. 1, 2, 3, 4. Number 4. We have 4 in 3 places. Then the next number we have there is 6. So we have 6. How many 6 do we have? We have 1, just 1 6. So we have 6. We have 6. We have 6. Next number there is 8. We have 8. How many 8 do we have? 1, 2, 3, 4, 8. So we'll write 8, 8, 8, 8, 8. Then the next one we have is we have according to the ascending order. So we have 12 as the next number there. So we have 12. How many 12 do we have? We have 1, 2, 3, 4, 12 as well. So write in 4 places. 12, 12, 12, 12. So have 12 in 4 places. The next number we have is we have 18. All right, we have 18. 18 is the next. So how many 18 do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. 18. So write 18 in 8 places. 18, 18, 18, 18, 1, 2, 3, 4, 18, 1, 2, 3, 4, 5, 8 places. 18, 18, 18. So have 1, 2, 3, 4, 5, 6, 7, 8, 18. So yes, then we have the next number that we have is 20. So have 1, 20, 1, 2, 3, 4, 5, 6, 20. So we have 20, 20, 20, 20, 1, 2, 3, 4, 20, 20. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So 20 in 6 places. 1, 2, 3, 4, 5, 6. So we count. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So it's not complete. So look at what is missing. Let's look at it again. How many 4s do we have? How many 2 do we have? 2 in 2 places. 1, 2. How many 4s do we have? We have 4. The first row, 1 4. Second, none. Third, none. Fourth row, we have 1 4 again. And then we have 4 in 3 places. So I have 1, 2, 3 4s. Abi? So we have, after that we have 6. How many 6 do we have? The first row, second row, just 1 6. We can see 1 6 there. How many 8s do we have? We have 8. 1, 2, 3, 4, 5. Okay, we have 8 in 5 places. So we'll add more 1 8 here. Okay. Have 8 in 5 places. 1, 2, 3, 4, 5. Then how many 12 do we have? Do we have 10? There is no 10. There is no 10. So look, be very careful so that you don't fail it, all right? So be careful as you do that. So there's no 10, we have 12. So how many 12 do we have? We have 1, 2, 3, 4, 4, 12. 1, 2, 3, 4. Let's check again. We have 1, 2, 3, 1, 2, 3, 4, 4, 12. So have 1, 2, 3, 4. So how many 18s do we have? First column 1, second column 1, that's 2. Third, fourth column 1, that's 3. 4, 5, 6, 7. Oh wait, 8. Have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9, 18. Okay, that's what missed it. So I have 9, 18. I have 1, 18 here. So I have 9, 18. So we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Now we are there. So we are there. So thank you very much. Now what do you do? We are going to construct what? A frequency table. All right. In economics, our variables are denominated as X. All right. So we do this. We do a table. We do this. This is our scores. All right. Our scores, which you can call what? Our X, our X, our observation. And then the next one is what? Our tally. All right. And then our frequency. Our frequency. So we do this. Okay. So let's go into it. We have the first one, which is 2. We have 2. We have 4. We have 6. We have 8. We have 12. We have 18. And then we have 20. 20. We have 20. So we can easily cross it out. We cross it out. We cross it out. We cross it out. Create a table already. We have our table already. You can see this table makes what simplified. Makes work simplified. Okay. So now we've made work simple for ourselves here already. See, by so doing, you have your work very cut out for you. So how many 2s do we have? In tally, we have what? 1 and 2. So we have what? 2 as a frequency. For 4, how many do we have? 1, 2, 3. So we have 1, 2, 3. That means we have what? 3 as a frequency. For 4, for 6, we have just 1. So we have what? 1 as a frequency. Then for 8, we have 1, 2, 3, 4, 5. So we have 1, 2, 3, 4, 5. That's how we do our tally. You cross the 5th one to give you 5. So we have what? 5 as a frequency. For 12, we have 1, 2, 3, 4. So for 12, we have 1, 2, 3, and 4. That means we have 4 as our frequency distribution. Then we have, for 18, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. So we have 9 as our frequency. The last one is 20. 1, 2, 3, 4, 5, 6. So we have 1, 2, 3, 4, 5, and 6. So we have what? 6 are frequencies. Exactly what you're looking for. This is what? A simple way to draw what? A frequency distribution table. All right? Thank you very much. And I believe that it's no longer an issue for you to be able to draw a frequency distribution table. So as we continue in our lesson, we have just shown you how to draw a frequency distribution table. So you can learn it, you just practice this. You can produce your own figures, your own variables, and do it again, all over again. You can pattern it anyway, make more than the others, and some very few. Yeah, of course, all right? So do it that way so that you can practice on your own, produce question for yourself, all right? And then let's go. Now, we're also looking at these tools. We have basic measures of central tendency, which is one of the tools we use for economics analysis. Here we have, we call them averages, all right? All averages are called what? Measures of central tendency. Now, average figures tend to be at the center of any set of data or information given, which is arranged in ascending order or descending order like we've done in that particular calculation we just did, also frequency table we just did. Right, so the most important average here is the mean, all right? The mean is what it means to be the central figure or value in a distribution, okay? Now, other values or averages represent the mode and the median. So these are going to be explained a little more, okay? Now, what is the median? The median is the number at the center, all right? The number, not the value, the number at the center in a distribution. Of course, when you have odd numbers, here the one we did before, we have even number. What we'll finish doing right now, we have even number. We had even number, okay? This distribution will have 30. If you have 29, all right? You remove 14 and 14. That one at the center becomes a median. Any value at the center becomes what? Your median. But if they are odd number, so if they're even number like 30 now, you will remove the two center and the 15th before the other 15th. The two 15th in the center, add it together divided by 2, give you what? The median value, all right? So that's what we'll do. Then the mode is most occurring. Like in that our distribution, I think 18 seems to be the highest number, which has 9 in number. So yeah, that's our mode value. So as the case may be, that's what we should know. So that's mode for you. And then what is the averages? What are they used for in economics? How are they useful in economics? Well, averages give us a summary of picture of quantitative values or data, especially in the use of what? Comparison. When you want to compare two options or two variables, it gives you a very, very, very strong representation of information given to you. You can compare two variables using what? The average, all right? Then mode helps us to determine the quantity of products to produce more, all right? The quantity of products to produce more, or that's more demanded for. Now, what are the mean advantages of mean? A mean will help us to simple calculation, all right? It is simple to calculate because you add up the total and divide by the number, you get what you mean. It has an exact value. It is exact when you get it, all right? Its principle is easy to understand. Its value is directly affected by the value of each item in the given data. Yes, because you have to add the total to get your mean, all right? It is good for purposes of comparison. When you want to do comparison, the mean is a very good variable to use to do that, okay? Then, how is it not so good in the use of our analysis? That is talking about the disadvantages of mean. Arithmetic mean cannot be obtained graphically, okay? Certain facts in arithmetic mean may not be revealed, all right? So some hidden values may not really see, okay? Some of them that have more values, like the one that has 9, the one that has only 1, will not be told you that this is it. There's improper representation of some values in the distribution, which will not be revealed by the mean, all right? It may be difficult to obtain without calculation. Like what I just did, if I want to get a mean for that frequency table I just provided, you have to do a lot of calculation there, okay? Then it can lead to distortion in result or distorted results, okay? It may be badly affected by extreme values in the distribution. Like I said, the one that has 9 and the one that has 1, it will be affected by that, okay? So that's one of the odd side of the mean. The median, it is easy to compute, all right? It's easy to understand and easy to compute even in incomplete data. Like I said, if it's odd number, the center one is your median number. If it's even number, they divide these two center numbers and to give you what? Your median value. It can be unrepresentative of the set of data. That's one of the disadvantages of a median. It can be what? It can be unrepresentative of the set of data in a distribution. Second disadvantage of the median is that in certain cases, there may be two or more modes in a distribution. So of course, you can't have that. The median might be abused, all right, be not properly represented. When you have the numbers that have two modes or more than one mode, all right, the median might be very, very not unrepresentative for distribution. The mode, of course, is easy to determine because it tells you of the highest or most occurring value in a distribution. It is easy to understand and then easy to compute, even for what incomplete data. Well, what are the disadvantages of the mode? The mode is not a very good measure of accuracy because it considers the most occurring. Okay, so the mean and the median might not be the most reliable figure. All right, it represents a very poor average. Of course, that's very true. It's irrelevant in further statistical calculation. The mode will not help you to make proper decisions when trying to come up with an average value for everybody's benefit. Okay, so based on this fact, we have been able to go through the basic measures of central word tendencies, okay, and tools of economic analysis. We're going to do more with measure of dispersion when we go to the next class. That's our next topic. We reward measures of word dispersion. But now, let's look at some possible questions you may face after you have studied this topic. Here are some possible questions you may find that may challenge you, all right, in this topic. Okay, so the first of them all will be this. The top question here says what? The diagram in figure 1 above depicts what? What does it represent? I told you is what? It's a component bar chart because one bar contains two variables, two items for a variable. The number here, 2000, all right, has, so 200 there, all right, 2001 has what? Two variables. The 2002 has two variables, but the heights are different. So it has what? A component bar chart as your answer. Then, the next question here says, the most frequently occurring value in a given data is what? Of course, the answer should be what? Should be your mode. Thank you very much. Now, the next question here is that we should calculate the median of the following score. The scores are what? The scores are 8, 9, 6, 5, 10. Also, we have 1, 2, 3, 4, 5 numbers. So it's easy to do. Just rearrange these numbers in ascending order. So I have 5, 6, 8, 9, 10. So what will be our median? The center number, because there are 5 in number, will be our median. That means our number will be what? 8. Because 8 will be the center, because I have 5, 6, 8, 9, 10. So our median will be what? Will be 8. So our answer will be what? B. You see, that's what we just learned now. Okay? Because of time, we will not be able to do this one. We'll check for another number that's easier for us to run. Okay? See, data presented in tables are usually arranged in what? Is it in charts and graphs? Is it in rows and columns? Is it in graphs and rows? Is it in column and charts? Answer is what? In rows and column. Last question that I'm going to take care to help us understand what we've done so far is not this. We're looking at the tools of economic analysis. Our question that will help us solve that will be this. Okay, let's see. It's a little bit more. Let's look at something that's simple, but you can do it, all right? You can do it. So which of the following tools of economic analysis is used when data contains more than the category? Oh, more than one category here. More than one. I don't know if it's more than one category. This is not very clear. Let's look at that question. Let's not assume that question because we might fail it. Okay, here you see, in a pie chart, the population of a city is presented by 45 degrees. If the country's population is 10 million people, then city's population will be what? What do? You divide 45 by 360 and times it by what? 10 million. Okay? That should give us, I don't have my pen here, but please calculate it. Let me look for another question that can help us finish up this exercise very well, please. That or not, I don't have a pen here to solve that for you, but please do that calculation and you have your answer very well represented for you. So a collection of data which has not been processed is referred to as what? It's referred to as a raw data. So yes, that is what we did when we had that one that we used to, we processed and gave us frequency distribution table. That will have this a raw data, okay? Thank you very much. God bless you. Meet you in our next class. Make sure you review your subjects and your topics. And please watch the video. Always visit your ExamGuide app to learn more and watch the videos as well. God bless you. Thank you very much. The best is for you.